Welcome to Lesson 4.7, Congruence Transformations video notes. We will be talking about transformations to help illustrate the topic of congruence and how that relates to the triangle congruence we've been talking about in Chapter 4. So let's get started. In the past, you've proved whether two triangles were congruent, and we've used side, 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 angle, angle, side, angle, 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 side, and hypotenuse leg to do that. We've also used CP, CTC to prove that specific parts are congruent. Well, now we're going to identify reflections, translations, rotations, and verify congruence after one of these kinds of transformations. So we'll take a look at what those things all mean. The new vocabulary, we've got quite a bit in this lesson. We've got what a transformation, preimage, and image are, congruence transformation, isometry, reflection, translation, and rotation. All right, let's take a look at some of our vocabulary. Now, rigid transformation really is just the same as what we call an isometry. The word rigid helps us understand that it is a strict or unmoving way of moving a figure where all the attributes of the figure stay fixed in the same position and size. And so we say that an isometry or rigid transformation is a mapping for which, that's the word an original figure and its image, what happens after you move it, are congruent. And we call this a congruence transformation also. And the position of the image and its original figure may differ. The original figure we call the pre-image, and after you move it, you call it the image. But the two figures remain congruent. There's three main types of congruence transformations, and they are shown right here. We have a reflection, translation, and rotation. Reflection is also thought of as a flip, and it is over a line called a line of reflection. Each point on the pre-image and its image are the same distance from that line of reflection. So C and H are the same distance from the line, B and G are the same distance from the line, A and F are the same distance from the line. A translation is also thought of as a slide. It moves all the points of the original figure the same distance in the same direction. So if I were to measure the segments connecting J to M, L to Q, and K to P, those are all going to be the same length, and those will all be parallel segments. And then a rotation or a turn is a transformation around a fixed point called the center of rotation through a specific angle and its specific direction. Each point of the original figure and its image are the same distance from the center. Okay, so each one of these is the same distance as its counterpart from that center of rotation. So let's see if we can do some examples. So we're going to identify, and a lot of these have been done for you here, but I'm going to highlight some specific parts. We're going to identify the type of congruence transformation shown as either a reflection, translation, or rotation. Remember, reflection is like a flip, translation is like a slide, and rotation is a turn. So for part A, we have our figure here. Sorry. There's our figure. And then we have the other figure after that transformation. And notice that every point and its counterpart are the same distance from this origin. Every vertex and its image are the same distance from the origin. The angles formed by each pair of corresponding points and the origin are congruent, so we call this a rotation. Now, if you're writing the answers to these on your own on an assignment or later on in the notes, this is all I'm really looking for. This is the explanation of how that answer is achieved. So let's look at part B. We have one figure on the left here, and its image over here on the right. Now notice every vertex of this figure is the same distance from this line, the y-axis, as its counterpart. This distance is the same as this one, and this one as this one, and this one as this one, and so on and so forth. We could go on and through all those vertices. So this is a reflection. We're reflecting that across that y-axis. And then lastly, part C here, this is our pre-image, and then this is our image. We started with this one actually if you follow the direction of those arrows. Okay, and every vertex is moving up and to the left. Up and to the left. In fact, each vertex moves up 3 to the left 3, and I could do that up 3 to the left 3 for each one of those vertices. So this is a translation. Alright, so I would like you to go ahead and try and name these three transformations as either a reflection, a translation, or a rotation. Give yourself enough time by pausing the video, but when you are ready to continue, click play. And if you've had enough time to complete these are the answers we should get. On 1A, you'll notice that this triangle on top has vertices that are the same distance away from the x-axis as their counterparts on the lower triangle. This vertex is 2 above, this vertex is 2 below. This vertex is 3 above, this vertex is 3 below. And then back to 1 above and 1 below. This is a reflection. And it is reflected over the x-axis. The x-axis is your line of reflection. On part B, you'll notice that we have this figure, and then it appears as though every vertex of this figure is the same distance from its counterpart in the other figure from the origin. Okay, if I wanted to compare distances from origin to these points, I could. And so this is a rotation around the origin. And then here, notice that these figures are in the same relative position. Okay, all the angles are still kind of pointing in the same direction on both, but we've gone from this figure and it looks as though each vertex has moved 1, 2, 3 and a half. 1, 2, 3 and a half. 1, 2, 3 and a half. 1, 2, 3 and a half to the right. So this is a translation. Alright, why don't you try and identify what each of these pictures could represent as either a reflection, translation, or rotation. If you need more time, pause the video. Otherwise, these are the answers we should get. When a van door slides along its track, we're taking this as the image of where it was originally. This is a translation. Okay, each vertex is moving along this same axis. Okay? And then if you look at the footprints in the sand, it appears as if one is a reflection of the other. Sorry, I spelled that wrong. Reflection, CT. All right, and we're gonna do most of this in the video, but I do want to kind of give you a heads up. It just in your note says to draw an example of a congruence transformation of a triangle. Do a reflection, a translation, and a rotation. You get to pick most of this that you do on your own, but I'm going to give you some guidelines. I'm going to give you your original figure, or what we call the pre-image in each one of these. For your reflection, I want you to reflect this triangle, A, B, C. I want you to reflect that over the y-axis. Okay? And then for the translation, I'm going to give you a different triangle. Okay? Call this triangle D, E, F. I want you to translate triangle DEF, and you can translate this any way you want. Remember, a translation is going to move every vertex in the same direction, the same number of places. This could be up, down, left, or right. You could translate these diagonally. Just think of rise over run as figuring out how you're going to move each vertex. But I'll let you pick your translation. And then on the rotation, I would like for you to rotate this triangle HGF. It's another right triangle, but I want you to rotate that around the origin, and I'll let you decide how far you rotate that. I would recommend increments of 90 degrees, either 90-degree rotation or 180-degree rotation or a 270-degree rotation. Not a 360-degree rotation. We'll talk about why that won't work out very well in class. But come up with these and we will check our answers together in class. This concludes our notes for Lesson 4.7. We will begin the assignment in class, but I have attached it to the Edmodo post if you would like to get started. Make sure that you grade any assignments from 4.5 and 4.6 that you have not graded yet. I'll attach answer keys for 4.6 with this Edmodo assignment also.